Hello everybody, welcome back. This is what would have been part 4 of making a Seax. Unfortunately, when I went to quench the piece, the blade itself suffered bad delamination along the edge weld. So at the moment it's about as useful as a third armpit. However, here's the process leading up to that moment. And we'll have a chat at the end about what I think went wrong. So this is the blade as of the end of the last couple of videos. You can see there are some rough file marks, and the spine itself is still a little rough. So before we go to heat treat it, we need to polish this up because it'll be easier to do at this stage rather than when it's hardened. So the easiest way to do this without causing any bending or warpage to the blade is to stick a block of wood in your vise and clamp the blade to that using a mole grip or vise. Now, a lot of people use sandpaper. I quite like using sharpening stones for this, and the reason I prefer stones is that they are self-cleaning, so they won't load up in the same way that sandpaper does. So wet the blade, wet the stone, and it works out a lot cheaper than sandpaper. I think I paid a tenner for my 3 stones, and they just cut through the metal a lot quicker as well. So I start off with a coarse stone to remove the bigger scratches. It's just a case of running it back and forth until all the scratches are gone. Now I only actually do this in one direction normally, so once I'm done with the coarse stone I will then move on to the medium stone and smooth that out, and that gives me a nice satin polish. And as you can see, it started highlighting the composite nature of the blade already. Now at this stage there's no signs whatsoever of it being a bad weld, but we will cover that at the end of the video. So after the polish I will move on to the heat treating. Now for this I will turn down my fire and I will make sure it's nice and dense and flat. Doesn't matter too much if it's an oxidizing fire because the blade isn't actually going in there, it's just going to lay on top of it. And this is the normalizing cycle. So I will get the blade up to critical temperature, which is known as the Curie point, which coincides with the blade becoming non-magnetic. The two aren't actually related, I believe. And I will hold it at that temperature on the fire for around 20 minutes, and then I will suspend it somewhere and just let it air cool. And this refines the grain of the steel and it will toughen up the welds a bit. And like I say, this process needs repeating 3 times. So my normal heat treating setup isn't big enough for the size of this blade, so I actually have a larger quench tank. It's basically a chimney flue with a bit of ceramic fleece in there and a capped off tube inside which will fill with oil, and the oil I'm using is sunflower oil. So I'm actually going to get the oil quite hot, and I'm going to heat it up to 220 degrees. And the reason for this is that it's a bit softer on a large blade. So I'm also using, in order to control the temperature more accurately, I'm using a thermocouple with 2 probes. The first probe I will set at the tip of the blade, and the second probe I will set at the centre of the blade itself. And the reason I'm doing this is purely because the heat doesn't like spreading through the oil. So I can have the top of the quench at a high temperature, and just a few inches below it, it will actually be quite cool, around 15-16 degrees room temperature. So in order to control this, I'll stick 2 probes in, and that will allow me to heat up the oil accurately. And in order to heat up the oil, I don't actually have a gas burner or an electric element in there. I am just using bars of hot metal, which I'll dip to the right depth in the quench tank in order to heat up all of the oil evenly. So in order to heat up the blade evenly, I will lay the blade on the fire and cover up the bits that are heating up slowly and leave the bits which are heating up faster uncovered. And it will just cook on the fire for 20 minutes. That will allow the grain to get where it wants to be. So stupidly the battery died and I missed out on the quench, but which has also made me a bit cross. But the blade was fully hardened, as demonstrated by the file test, and here's the end result. Now, I didn't actually shoot any more footage of cleaning up the blade post heat treating. I cleaned it up and etched it in order to show what went wrong. Now, I believe that the welds were sound to start with. I think that what went wrong is that the blade itself was simply too thick, and when I quenched it, the edge cooled a lot faster than the rest of the blade, and the weld just wasn't strong enough to hold it together, so it split at that point. I did get a tiny bit of warpage in the blade as well. Now, considering that it was normalised 3 times, each normalisation was 20 minutes, and then whatever time it took to air cool, I don't think that the normalising was at fault. I think it was the blade geometry. Now, I got a bit of deflection in the point of the blade, and this is potentially also what contributed to the weld failing. I'm a bit disgusted that this has happened at this stage of the project. I have made blades like this before. Here are some images of one I made a couple of months back, and as you can see, nothing's gone wrong on this one. I don't believe it's the process other than the shaping of the blade that's at fault. So I'm not quite sure where I go from here. I may remake the blade, I may move on to another project and do some pattern welding again at some further point. It's a bit disappointing for me. I can imagine it's quite disappointing for you guys. I'm very sorry about this. So, thanks for watching. Sorry it's been a bit of a letdown. I will see you on the next one. Bye.